Similar triangles have all three angles in common, but are different sizes. If the sides were the same and the angles were the same, then they would be congruent triangles. In this case, we're given two triangles and we're asked to try to find if they are similar or not. Well, if they're similar, then all three angles must be the same. So the three angles, 90 plus 35 plus the unknown angle, must equal 180 degrees. We add the 90 plus 35, gives us 125 plus x, then we subtract 125 from both sides. We see that x is 55 degrees. Well, if this angle up here is 55 degrees, then these two angles over here are going to be 25 and 65, so these are not similar triangles. Let's say that we're asked to find the distance across a lake. Given two triangles set up as we see them here, standing on one side of this river, we're able to tell the distance of the river because the two triangles in question here are proportional to each other. So this smaller triangle, an x, would represent the distance across the river, and we're indirectly able to measure across the river by setting up a proportion. So we set up a first fraction as just the names small and large. All the parts for the small triangle will go on the top, and all the parts for the large triangle on the bottom. So the small triangle's height is x, and the large triangle's height is x plus 115. And then looking at the bases of the two triangles, the small one is 210 and the large one is 275. Now, in order to solve this, we simply use cross products, and the cross products give us 275 times x, and then on the other direction, that's going to be set equal to 210 times x, it's 210x, and 210 times 115 is 24,150. Now we just solved the two-step equation. First thing I want to do is subtract 210 from both sides. Leaves us with 65x equals 24,150. Then I divide both sides by 65, which gives us approximately 372 feet. In this example, you're standing here and you want to know the height of this tree. Well, that forms two similar triangles. This one here we're able to measure because you're standing here. And the other height, which is that of the tree, is the unknown, and we'll put an x over here. So again, we want to set up a proportion. So we're going to do small triangle, large triangle. Now for the small triangle, we know that the height is 1.75 meters. The height of the tree is just given as an x, so we'll put that here. And then the other part that we're aware of is we know the distance from this point over here to the tree is 41.75, so that distance we'll put here, 41.35 meters. And then the distance for the bottom of the smaller triangle would be 41.35 minus 36.9. So to solve this, we'll go ahead and solve the cross products. So 4.45 times x is going to equal 1.75 times 41.35 is 72.3625. And then we solve the one-step equation by dividing both sides by 4.45. And we get x is approximately 16.3 meters, which is the height of the tree. In this example, we're asked to find the height of a flagpole, and the only thing that we have is a tape measure and a mirror. And here on the ground, we can see that the mirror is there, and anytime you put a mirror on the ground, regardless of how far you stand from the mirror, if you move your body to be in a position where you can see the top of the flagpole in the mirror, these two angles over here will be equal to each other. And you've also created right angles here and here from your body to the ground. So you've created two similar triangles. So we start again with forming a proportion. So we need small and large triangles. The purpose of the first fraction is so that you don't mix up which things go in the top and which things go in the bottom. So I start by forming this proportion. The small triangle's base is 1.1 and the large triangle's base is 8.85. And then the height of the flagpole I don't know, but I know that my height is 1.15 meters. To solve this, I do the cross products, which will give me 1.1x, which will equal 8.85 times 1.15, which is 10.1775. I then divide both sides by 1.1, which then gives me that x is approximately 9.3 meters. In this example, we want to find the distance across the widest point of a lake, and we're able to measure on one side of the lake. So again, we have two triangles, and the distance across the lake is the unknown, so we'll put x there. So we'll start off by forming the proportion. So I have small divided by large is going to equal, and then our two fractions are going to be, this point of the smaller triangle is 109.5. The distance across the lake is the unknown, that's x. Then I have the base of the smaller triangle is 125. Then I have the base of the bigger triangle, which is 95 plus 125, which is 220. Now that I've set up the proportion, I simply do the cross products, which gives me 125 times x and 109.5 times 220, which is 24,090. Then in order to solve the one-step equation, I divide both sides by 125, which gives me x is approximately 192.7 meters. Here we have two triangles that are similar. We know that by the angles are equal, but the length of the sides are not. And even though the orientation, this one is rotated slightly to the left, I'm still able to find the missing value by setting up a proportion. So I do that by small and large for my fraction. This is just simply for the names. The first fraction, 92 and 23. The smaller triangle is 23. The larger one is 92. And the other sides are 73 and x. The x goes with the smaller, and the 73 goes with the larger. And then I'm going to do the cross products to solve for x. So I get 92x, and 23 times 73 is 1679. And then I divide both sides by 92, which gives us the length of the missing side is 18.25.